Right, welcome to week 10, video 7. So in the first 5 videos, was it, we talked about how you can write classes in Python. And then that moves on to the more interesting question of, given that you can do that, how does this alter how you go about programming a solution to some problem? And that raises the question then, how do you decide what the classes are? And then we'll work through an example, namely we'll try to write a noughts and crosses program using OO type approaches. So where do classes come from? Similar question to the one I asked in functions. I said, where do functions come from? And the first way that functions arose was by discovery. And the same thing applies in classes, and I've already mentioned this in the last video. If you find a group of values that tend to go together, such as an x, y, and z coordinate, you're passing them around, then, oh, hey, maybe there's a class here, a class point. There's a red, green, and blue color components. Maybe I should have a color class. That sort of discovery type process takes place if you're adopting a procedural initial design strategy, and then it evolves into OO. But better, as always, is to avoid wasting time going down the wrong path in the first place and to design it right straight off. And you know, this is ideal. None of us ever quite achieve that, but it's a goal, worthwhile goal. So for OO top-down design, rather than what are the functions that we need to write, we have to ask the question, what are the classes that we need to write? So to try and explain that, I'm going to go through a worked example of noughts and crosses. I'm not going to go through it in its entirety. I'm just going to introduce the idea of object-oriented design. So, key idea is that we're going to start with trying to figure out what are the set of classes that we're going to need. We won't get it right. We won't, well, there's no right, but we will certainly need to change our mind along the line, because we'll either have an incomplete set or we'll have some classes that don't work. But anyway, as a starting point, often what you need to do is look through the specifications for what it is you're trying to do. In this case, the specifications would be the rules of tic-tac-toe, and you can read them in that Wikipedia article if you like. You may even want to do that now. Have a look through, look at the nouns, and see if those nouns, which are objects in the real world game, do they correspond to objects in the programmed game? And you have to make that decision. And that's what we're going to do. So here's some of the words that would come up in that spec. A tic-tac-toe or noughts and crosses game is played by 2 players with a 3x3 board, and the object of the players is to get lines of their piece 3 in a row, or 3 in a column, or 3 on a diagonal. So those are some nouns. There's a lot of others, of course, in that spec. And I'm going to focus on the top 3, the big 3 if you like. What is a game, what's a player, what's a board? So with OO design, we have to decide fairly early on what are at least some of the fields that the object needs, what are its attributes, what are its instance variables, and what does it do? How does it behave? What are the methods? So I've tried to get vaguely the idea of how your thinking might go. Now this is just to be skimmed over to give you vague ideas, really. Let's think about the game class. So what are the attributes of a game? Well, if you looked at the spec again, the article on tic-tac-toe, you'd discover, of course, that a game is played by 2 players. And so a game, in order to be played, has to have 2 players, and it has to have a board. So you could think that, okay, if I'm going to define this game class, and I'm going to give it an init method because every good house should have one, we're going to have some stuff in here, which is, at very least, we're going to have 2 players, and we're going to have a board. I say at very least, we might actually generate them within the game. They don't have to be passed in as parameters. That's always possible. But if we did do it this way, then I'm going to say self.player1 is player1, and so on. And I'm not going to write all the code. That'd be thoroughly tedious. That's what a game consists of: 2 players and a board, maybe some other stuff. That'll do for a start. What are the methods of a game? Well, what do you do to games? Well, you play them. So it seems like we're going to have a method play, which is going to do something, and I'm not sure how. And I've come up with a suggestion that you would ask, what else do you have on games? What do you ask a game? If you think of it as an actor in the real world and you represent a game and I ask you, is the game over? Who won? So these might be methods. I might have game is over as a method. I might have the winner as a method. And these are just possibilities. I can jot them all down and we'll worry about the details later on. That's a game. What about a board? Well, a board, it's a class again. What does a board have? Well, we have to have a representation of the board. It has to somehow or other be able to represent the 3x3 grid. So probably the one we used before in the procedural version will do. What are its methods? Well, I've suggested here maybe it has a make a move method. So a particular player would move to a particular square. And what's a class player, and so on. I don't want to go through all the details. I'm going to jump to this thing here, which is called a class diagram. This was automatically generated by code from my solution, but quite often what OO designers do is they start using a different tool. They start trying to design the classes like this before writing any code at all. This is one of the powers of OO. It does make it possible to do to have methodologies for designing at quite a high level. This is called a UML diagram, or it's a one type of UML diagram, and that stands for Unified Modeling Language. You'll find out more about that in Cinch 201 if you're a software engineer. And so here I'm representing by these boxes the classes I've got. So this thing contains arrow, so a noughts and crosses game contains a board, and it contains player 1 and player 2, which are of class player. The board is of class board. So then below the class name I have the attributes of the class. So it has player 1, player 2. It has a current player, which I didn't come up with before, has a board. And the methods it seems to have is you can play it, you can ask if the game is over, you can switch to the next player, you can ask who the winner is, you can ask is the game won or is it a draw. So these are the methods. Now, like I say, if this is top-down design, you'll make mistakes. The methods you will suggest here will turn out to be inadequate or unnecessary or whatever. A player, what's a player? Well, here I've suggested a player. It consists of a particular piece, O or X, and the name of the player. And to try to illustrate why I think the name of the player might be of some use, let's look at the code that was used to generate this UML diagram. So here it is. This is the top level code. It says from player import player, from game import game. If it's the main function, generate the first player, generate the second player, and construct a game of those two players. I didn't construct a board and pass it in. I chose in this implementation to construct the board within the game. That works too. And then I play the game, simple as that. So if I run that code, it should work, and here it is. So it displays the game and asks Angus, who is O, to enter a move. So Angus says, I'm going to go at 0, 0, and now it asks Zelda to enter a move. So much nicer to have a name rather than just O or X, which is all we had in the procedural version. That's why there's a name here. Board, I'm not going to go into board. I'm not very happy with my implementation of board. I'm not saying I got the code right. There is no such thing as right, and I'm not even saying I necessarily found a great solution. You may want to look through the code. It's available and learn. But just to quickly show you one bit of it, here's the game, which has an init method, which takes just 2 players, stores them in the self object, defines the first player to be player 1, and initializes an empty board. We've got from board import board at the top. That defines the class. And then play consists of while not game over, print the board, ask the current player what move they want to make, and set the board at that row and column to that current player's piece. So you may want to pause the video and study that code a little bit, or fish the code off, learn and study it more, just to get the idea of what OO code might look like. That's all I wanted to do, just give you a taste of OO programming. Hope I've succeeded in that. Thanks for watching. Bye.